So in this video, we will be solving some typical problems in Newton's laws of motion. So before we start, I would request please like and subscribe my channel. Thank you. So our first question is, a bullet of mass 0.01 kg is fired horizontally into a 4 kg wooden block. So it's a 4 kg wooden block at rest on a horizontal surface. Now the coefficient of kinetic friction between the block and the surface is 0.25. The bullet remains embedded in the block and the combination moves 20 meter. So it moves 20 meter before coming to rest. With what speed did the bullet strikes the block? Okay, first of all, we'll write whatever is given to us in the question. Now see, here the mass of the bullet m1 is how much? 0.01 kg. So m1 is 0.01 kg. Mass of the wooden block m2. Now taking this as m2 is how much? 4 kg. Coefficient of kinetic friction mu, which is 0.25. Let the velocity the distance moved by the combination s is how much? 20 meter. Okay. Now let the velocity of the bullet be u1. So u1, velocity of the bullet is u1, and we know that the initial velocity of the block u2 is 0. Okay, u1 is, this is the velocity of the bullet, bu1. So we have to find actually u1 only. Now we take v. Let v be the velocity with which the combination moves. Now if u1 is the velocity of bullet, and u2 is basically that velocity of that wooden block. Now considering v. Now v is the velocity. V is velocity of that combination. Combination means that when the bullet is embedded into the wooden block. Now by the principle of conservation of momentum. Now see, m1 plus m2 v. Why? Because now the bullet is embedded inside it. So m1 plus m2, mass of block and the bullet into the combined velocity, that is equals to the initial momentum of the bullet plus the initial momentum of the wooden block. Now substituting this value. Now what is this m1? Mass of the bullet, taking m1 as 0. We have taken m1 as 0.01 plus m2 as 4 into v. This is equals to m1 u1, 0.01 u1 plus this will be 4 into 0 because this is actually u2. So this is 0. Now v, what will be v? Now v is basically, this is 0.01 of u1 upon 4.01, because 4 plus 0.01 is 4.01, or you can state this as, removing the decimals 1, 2, 1, 2, this will be u1 upon 401. So if you see the relation, the velocity of the combination is actually 401 times less than that of the velocity of the bullet. Now the force of dynamic friction of the combination. Now see, we know that F is equals to mu r, which is equals to mu. Now what is this normal reaction? Mass of both m1 plus m2 of g. Okay, now substituting this value, this is how much is mu? 0.25. m1 plus m2 is 0.01 plus m2 is actually 4, and this is into 9.8. Okay, so this is the force, taking this as force. Now see, what is the retardation produced? The retardation produced, A, will be given as F upon m1 plus m2. Now substituting the value of F. Now this is the value of F, which is 0.25. This will be into 4.01 into 9.8, this whole upon m1 plus m2 is, we know that, 4.01. So if A, you will get A 2.45 meter per second square. This is the retardation of that combination, like when the bullet is embedded inside the wooden block. Now, using the third equation of motion, we can get V, which V is what V? This V, the velocity of the combination. Okay. So, finding V. Using third equation of motion, V square minus U square equals 2AS. Okay. This is 0 minus this initial velocity is V square equals 2. This is minus 4 point, this is 2.45, and into S we know that it has moved 20 meter. Okay. Now this V square is so this V square is minus will get cancelled. So this will be 2 into 2.45 into 20, which is 2.45 into 2 is 4.9 into 20. 4.9 into 20 is 98, or V is how much? Root 98. Now see, again, see, if you look at this equation, V square minus U square is 2S. Now V here, V is actually the block is finally coming to rest. So that final velocity of the block is 0, and initial velocity is V, the velocity of that combination. So this V is root 98. Now if we look at this equation, it was V. V is U1 upon 401. So this V is root 98. What is U1? U1 will be root 98 into 401. So using that equation, V is how much? Root 98 equals U1 upon 401. So this U1, which is the velocity of bullet, is root 98 times 401. So if you solve it, this comes out to be 3969 meter per second, or 3970 meter per second after rounding off. So this is the velocity of the bullet. Our next example, a ball of mass 10 gram is suspended by a string 40 centimeter long. So this is 40 centimeter long. Keeping the string always taut, the ball describes a horizontal circle of radius 10 centimeter. Find the angular speed. Now here you have to find the angular speed. Now see, this is the diagram. Okay, you consider this point. The mass of the ball is 100 gram, which is 0.1 kg. Length of the string, which is OP. Radius of circle, this is radius of circle. CP is the radius of circle. Okay, and this is the angle theta. So let the string makes an angle theta with the vertical. This is vertical is OC. Now see, we can first of all write the values which is given to us. So let's solve in this only. Okay. Now see, here M is how much? M is 100 grams, which is 0.1 kg. M was, sorry, this is not 10, this is 100 gram, sorry, 100 gram. This is 0.1 kg. Okay. Now, length of the string is basically OP. This is the length of the string. So, OP is actually 40 centimeter. So, converting this to meter, this is 0.4 meter. This is 0.4 meter. So, 40 centimeter long. Keeping the string always taut, the ball describes a horizontal circle of radius. Now, radius is 10 centimeter. So, we take radius R, which is this, radius R, this R as 10 centimeter, which is 0.1 meter, 10 0.1 meter. So see, let the string makes an angle theta with the vertical OC as shown in figure. And this is the figure. Now see, this is the tension T, this is theta, so this will be theta. Resolving them, see, this is the weight mg which will act vertically downward. Resolving this T, this will be T cos theta, T sin theta. T cos theta will be balanced by mg. Now see, look at this triangle, this one. What will be sine theta? Sine theta will be Cp upon OP. Now sine theta will be Cp upon OP. What is Cp? We know that Cp is how much? Cp is 0.1, OP is 0.4, which is 1 by 4. So if you solve, theta is sine inverse 1 by 4, which is equals 14.48 degree. So this is the angle, 14.48 degree, this is the angle. Now, again let T be the tension in the string, which can be resolved. We have already resolved into two rectangular components. As you can see, T cos theta, vertically effort, which balances the weight, T sin theta along, you can see this PC, which provides necessary centripetal force. So it is the T sin theta which is providing the necessary centripetal force. So we can write this T sin theta is equals m v square by r. But according to question, we have to find the angular speed. So we have to find the angular speed. So sin theta is mv square by r, which is equals to m r omega square. This we have already done. And we know that T cos theta equals mg. Now taking this equation 1, equation 2, doing 1 by 2 means 1 divided by 2. So let's 1 divided by 2. So that will be T sin theta, that will be T sin theta by T cos theta, which is equals to m r omega square by mg. You know that this will become tan theta. So tan theta is equals, this tan theta is equals r omega square by g. Okay, now we have to find omega. So this will be g tan theta by r equals omega square. Now under root of g tan theta by r equals omega. Substituting the values. So this will be under root of, this is 9.8, tan theta is tan 14.48 upon r, which is 0.1, which is equals to omega. So this omega is actually equals 5.0. When you solve this, you get 5.03 radian per second.